On the morning of October 22nd, in the year 2025, a single quiet announcement detonated inside the most powerful technology companies on Earth. Google's quantum team revealed that a fingernail-sized chip called Willow had just done something no machine in the history of human civilization had ever done before. It ran a calculation that would take the fastest supercomputer on the planet an unthinkable stretch of years, and it finished that same calculation in a matter of hours, 13,000 times faster. And, for the first time ever, the answer could be independently verified on another machine, which meant this was not a lucky trick or a laboratory illusion. It was real. Within days, in boardrooms from California to New York, executives who had just committed over $1 trillion to building the largest computing infrastructure in the history of the world sat frozen in front of a single terrifying question. What if every dollar of it becomes worthless? Imagine waking up one morning and finding out that the single biggest technology investment in human history, over $1 trillion being poured into massive artificial intelligence data centers right now, could all become completely obsolete. Not in 50 years, not in 20, but possibly within this very decade. That is not a nightmare scenario ripped from a science fiction film. That is the exact conversation happening right now inside the most powerful companies on the planet. And the thing responsible for all of this fear is not a smarter chatbot. It is not a faster chip. It is not even a new piece of software. It is quantum computing, a technology so fundamentally different from everything we have ever built that scientists are still struggling to find the right words to describe it. And right now, in 2026, it is beginning to do something almost nobody expected this soon. It is starting to kill the AI data center industry as we know it. To understand why this is such an enormous deal, you first need to grasp just how insane the AI data center boom has become. We are not talking about a few server rooms getting an upgrade. We are talking about one of the most expensive construction efforts in the history of civilization. In 2025 alone, the world spent an estimated $580 billion on AI-focused data center infrastructure. That number is almost impossible to wrap your head around. Microsoft committed over $80 billion in capital spending for a single fiscal year. Meta signaled it would spend somewhere between $80 billion and $100 billion in a single year, up sharply from $70 billion the year before. Google, Amazon, and every major cloud giant on the map are locked in a desperate race to build the biggest, most powerful AI computing facilities that money can possibly buy. These are not ordinary buildings. Some of these campuses stretch across land the size of small towns, drawing enough electricity on their own to power a mid-sized city, and they are being thrown up at a pace the world has never witnessed before. The scale of ambition here is almost beyond comprehension, and the men signing these checks are betting the entire future of their companies on a single assumption, that the machines they are building today will still matter tomorrow. And if you think all that money stays neatly inside the technology industry, think again. Utilities in the United States alone are planning around $1.4 trillion in spending just to supply electricity to these data centers. Power bills for ordinary American families have already climbed nearly 40% since 2021, largely because of this exploding demand. And some estimates suggest consumers could end up absorbing $700 billion of that total through rate hikes on their monthly bills. So if you are sitting at home wondering why your electricity keeps getting more expensive every single year, now you have your answer. And if that alone does not unsettle you, make sure you hit that like and subscribe button right now, because what comes next is far more shocking. The AI data center energy problem is no longer just an economic headache. It is becoming a full-blown crisis. The International Energy Agency now projects that global data center electricity consumption will push past 1,000 terawatt hours by the end of 2026. To put that into perspective, that is roughly the equivalent of the entire annual electricity usage of Japan, an advanced nation of over 120 million people, consumed just by data centers. Some estimates now suggest that AI-driven facilities already consume more power than entire countries. In Ireland, data centers already account for around 21% of the nation's total electricity consumption, and that figure is forecast to climb toward 32% within this year. In the United States, total data center energy demand is projected to nearly double from around 80 gigawatts to 150 gigawatts before the end of the decade. And here is the part almost nobody is talking about loudly enough. This explosive demand is crashing headfirst into a power grid that simply cannot keep up. Projects that secured land and financing years ago are sitting completely stalled, waiting in grid connection queues that now stretch 3 to 7 years in major utility regions. Data center cancellations caused by local community pushback actually quadrupled in a single year, with at least 25 major projects scrapped outright. One American state became the first to pass a full moratorium on large data center construction. The AI industry built itself a monster, and now that monster is eating the power grid alive. So what does any of this have to do with quantum computing? The answer is everything, and here is exactly why. Every single AI model you have ever used, every chatbot conversation, every generated image, every video rendered by artificial intelligence, all of it runs on classical computing power. Classical computers, even the most advanced machines ever built, work by processing bits. Every bit is either a 0 or a 1. Simple, reliable, and brutally energy hungry at the scale that modern AI now demands. Training just one large AI model can burn through as much electricity as several average homes would use across their entire lifetimes. And running that model afterward, what engineers call inference, happens billions of times every single day across the internet, devouring staggering amounts of power around the clock, every hour, every day, every week of the year. The entire AI data center empire exists for one reason. Classical computing has been the only tool we ever had to do this job. But quantum computing does not play by those rules, and that single fact changes everything. Quantum computers do not use bits, they use qubits. And a qubit can exist as a 0, a 1, or both at the very same time, a strange phenomenon called superposition. On top of that, qubits can be entangled with one another, meaning the state of one can instantly influence another, no matter how far apart they sit. Together, these two properties allow a quantum machine to explore an almost unimaginable number of possibilities all at once, rather than crawling through them one at a time the way a classical computer must. The practical result of this is genuinely mind-bending. Industry analysts have described the field approaching a machine that could solve in about 200 seconds a problem that would take a conventional supercomputer 10,000 years. Read that again, slowly. 200 seconds against 10,000 years. That is not an improvement. That is not an upgrade. That is an entirely different category of machine. And here is where the quantum story and the AI data center story collide in a way that should genuinely frighten anyone who has bet billions of dollars on traditional computing. In a span of barely 2 years, the three biggest names in quantum computing, Google, IBM, and Microsoft, each crossed into territory that was considered pure theory only a short time ago. Google's Willow chip, unveiled with its quantum echoes breakthrough, demonstrated the first ever verifiable quantum advantage, running a specific algorithm 13,000 times faster than the world's fastest classical supercomputers. It packed 105 qubits, and the result was so solid that it was published in one of the most respected scientific journals on Earth. These were no longer marketing slides. This was hardware doing what hardware was never supposed to be able to do. IBM, meanwhile, has laid out one of the most aggressive and detailed roadmaps in the entire industry, openly targeting a genuine quantum advantage by the end of 2026 and the world's first large-scale fault-tolerant quantum computer, a machine it calls Starling, by 2029. That system is being built in Poughkeepsie, New York, at one of the most historic sites in the entire story of computing, and it is designed to run 100 million quantum operations across 200 logical qubits. Microsoft took a completely different path. In February of 2025, it revealed a chip called Majorana 1, built on an entirely new class of material it named a topoconductor, engineered atom by atom from indium arsenide and aluminum. Microsoft claims this design bakes error resistance directly into the hardware and offers a path to fit 1 million qubits onto a single chip that sits in the palm of your hand. Experts called it a transformative leap. The race, in other words, is no longer theoretical. It is happening right now in real laboratories with real machines producing real results. The specific threat that quantum computing poses to AI data centers comes down to one word that cannot be overstated: efficiency. Because here's a secret about what these massive AI facilities actually spend most of their time doing. The majority of it is optimization, the endless hunt for the single best solution among billions or trillions of possible options. Training a neural network is an optimization problem. So is fraud detection, so are recommendation engines, so is drug discovery, so is logistics, so is financial modeling. And optimization is exactly the category of problem where quantum computing achieves its most dramatic and jaw-dropping advantages. Quantum annealing systems and hybrid quantum classical machines are already beginning to chew through optimization tasks that would trap a classical supercomputer for days or weeks and solving them in minutes or hours instead. Now follow the logic all the way to the end, because this is where the trillion-dollar empire begins to crack. When quantum computers can routinely handle these workloads at scale, the need for hundreds of thousands of classical graphics processors, the very machines that fill today's AI data centers wall-to-wall, begins to drop dramatically. Not to zero, but dramatically. The energy equation flips, the infrastructure equation flips, and that mountain of money already buried in massive classical computing warehouses suddenly starts to look very, very different. What makes this even more dangerous for those investors is that the disruption does not require quantum machines to fully replace classical computing overnight. The damage begins long before that moment ever arrives. The instant a credible timeline for practical quantum advantage becomes clear, Many experts now place that timeline somewhere between 2028 and 2030 for fault-tolerant, commercially viable systems. The entire economics of building new classical AI data centers begins to break. Ask yourself the question every chief executive is now quietly asking. Why would a company spend $5 billion building a brand new classical processor data center today if credible quantum hardware is expected to be commercially available within just a few short years? The investment math shifts, capital flows shift, and the companies that have already sunk billions into classical infrastructure are left staring at an increasingly uncomfortable question about how much those assets will really be worth. Google's own chief executive has publicly stated that the company is optimistic. Practical quantum workloads will emerge within about 5 years. That is not a vague, futuristic daydream. That is a leader telling the entire market to start preparing right now. And the energy dimension of this story cannot be pushed aside because it may be the single most powerful force driving quantum computing's rise. Classical AI data centers do not merely use electricity. They devour it without mercy. The quantum alternative, by contrast, is radically more efficient for each unit of useful work performed. The quantum processors themselves consume relatively little power during the actual computation. The truly energy-hungry part is the cryogenic cooling needed to hold the qubits at temperatures near absolute zero, colder than the depths of outer space. But here is the difference that changes the entire equation. One quantum processor running millions of calculations at once uses a tiny fraction of the energy that hundreds of thousands of classical processors would need to grind through the same work one step at a time. If this is the kind of shift that could reshape the entire global economy, and it truly is, then take 1 second and hit that subscribe button because this story is only getting bigger. The most realistic promise of quantum computing is not to erase data centers from the planet entirely. It is to dramatically shrink the energy and the physical footprint required for each unit of AI work performed. That is a revolution in efficiency, not merely a new box of hardware. And in a world where AI energy demand is already climbing toward the entire national electricity consumption of Japan, that efficiency revolution is not a pleasant bonus. It is fast becoming an existential necessity for the survival of the grids we all depend on. The geopolitical dimension of this story is equally staggering and equally underreported. Global investment tracking has traced tens of billions of dollars flooding into quantum technology, with the total now widely reported to have surged past $55 billion in a single recent year alone. Governments across the United States, China, Europe, South Korea, and Japan are treating quantum computing as a matter of raw national security, not merely industrial competition. The race for quantum supremacy is not just about who gets to sell a better machine. It is about who controls the next generation of encryption, of military logistics, of pharmaceutical discovery, of financial modeling, and of artificial intelligence itself. The nation or company that reaches fault-tolerant quantum computing first will hold an advantage over its classical rivals comparable to the advantage a modern fighter jet holds over a wooden biplane from a century ago. And the countries that built their entire digital economies on classical AI data centers will face a painful and staggeringly expensive transition if they miss the quantum window. There is also a darker side to this story that deserves your full attention, one that has nothing to do with efficiency and everything to do with security. As quantum machines grow more powerful, they pose an existential threat to the very encryption that protects every piece of data inside every AI data center on Earth. The encryption methods we rely on today, the invisible digital locks that guard bank transfers, government secrets, corporate files, and your own personal information, are all built on mathematical problems that are practically impossible for classical computers to crack in any reasonable amount of time. Quantum computers will one day be able to shatter many of those locks with frightening ease. This is not a distant fantasy. The cybersecurity world already has a chilling name for it. They call it Q-Day, the moment a quantum machine becomes powerful enough to break standard encryption wide open. Banks, government agencies, and major corporations are now being warned that quantum-safe security protocols will be essential inside enterprise data centers before the end of this decade. International standards bodies are already racing to develop new frameworks to defend against this exact threat. The uncomfortable truth is that many of the data centers being built today will need to be rebuilt, or at the very least, deeply retrofitted, just to survive in a world where quantum computers can pick the old locks. That is another layer of cost. That is another layer of disruption. And it is one more reason the AI data center model, exactly as it exists today, may be running on borrowed time. What makes this entire saga even more fascinating is the open disagreement at the very top of the technology world about how fast all of this is truly moving. In January of 2025, at a major electronics show, the chief executive of NVIDIA, the company whose chips power almost the entire AI boom, famously declared that genuinely useful quantum computers were still 15 to 30 years away. and that classical accelerated computing would remain dominant for a very long time. His words landed like a bomb. Quantum computing stocks crashed almost instantly, with some of the best-known names in the field losing 39 and even 45% of their value in a single brutal trading day. To the skeptics, it felt like the final word from the most powerful man in computing. But less than 1 year later, that same man was standing on a stage, doing something almost unheard of for a chief executive. He publicly admitted he had been wrong. At his own company's quantum event, he joked that it was the first time in history a chief executive had invited a room full of guests specifically to explain why his prediction had missed. He walked back his 15 to 30-year estimate, declaring that quantum computing was now reaching an inflection point. And then his company launched its own quantum-focused platform, a family of open tools designed to tackle the exact error correction problems that had slowed quantum hardware for years. The instant that reversal became clear, the very same quantum stocks he had crushed a year earlier came roaring back, some of them soaring more than 20% in a single day. Even the loudest skeptic in the entire room was now quietly hedging his bets. That alone should tell you everything you need to know about which way the wind is now blowing. By 2026, even the most doubtful voices in the industry were forced to admit the uncomfortable reality. The quantum timeline is compressing far faster than conventional wisdom ever predicted. Breakthrough after breakthrough kept arriving, each one landing harder than the last. From verifiable quantum advantage to topological chips, to detailed roadmaps pointing straight at fault-tolerant systems by the end of the decade. And here is what all of this actually means for the future in plain, practical terms. The AI data center industry is not going to collapse next Tuesday. Classical computers are not vanishing overnight. But the shape of computing in 2030 and beyond is not going to be endless warehouses of graphics processors swallowing more electricity than entire nations. It is going to be a hybrid world. Quantum processors will handle the most complex optimization and simulation problems, the tasks where they crush classical machines. Classical systems will handle data storage, simpler everyday workloads, and the vast ocean of ordinary operations. But the center of gravity is unmistakably shifting. The companies and governments that understand this shift and begin positioning for it now will be the ones that dominate the next decade. The ones that assume today's AI data center model is permanent and keep pouring capital into it without accounting for the quantum disruption ahead are making a bet that history may one day judge very harshly indeed. And the industry itself is already beginning to adapt, slowly but unmistakably. Major data center operators and cloud giants are now quietly adding what industry reports describe as dedicated quantum zones inside their facilities, specialized areas designed to host quantum coprocessors right alongside classical hardware. One respected forecast projects that within a handful of years, a growing share of the world's most advanced data centers will host quantum coprocessors for research and enterprise simulation. IBM is already running a quantum computer right next to a classical supercomputer. Microsoft has been pushing a quantum processor designed to fit inside the footprint of a standard server rack. And NVIDIA, the same company whose chief executive once doubted the entire timeline, has now built and released tools specifically designed to manage the error correction challenges that have historically plagued quantum hardware. When even the greatest skeptic in the room is busy hedging his bets, that tells you exactly where this is all heading. And there is one final angle that deserves your attention before we close this out, one that touches ordinary people far more directly than almost any technology coverage ever admits. The AI data center boom, in its current form, is quietly being subsidized by everyday consumers through rising electricity prices, tax breaks, and utility rate hikes. And those consumers are getting almost nothing in return. That $1.4 trillion that American utilities plan to spend upgrading the power grid for these data centers is not being paid for by the tech giants alone. Estimates suggest ordinary households could end up absorbing close to half of that total, roughly $700 billion, quietly passed down through higher monthly bills. Meanwhile, family electricity costs have already jumped around 40% in just a few years, and major financial analysts have warned that data center-driven power demand could keep pushing core inflation higher for years to come. An energy policy expert put it plainly when she noted that when a single data center campus consumes more power than 100,000 homes, the traditional model of sharing those costs fairly simply breaks down. Ordinary people are paying to power a technological revolution that is reshaping the entire economy, and most of them have no idea it is even happening. So when quantum computing finally arrives and begins delivering the same or greater AI capability at a fraction of the energy cost, that will not just be a victory for tech companies, it will be genuine relief for strained power grids, for climbing electricity prices, and for every household quietly footing the bill for the AI boom without ever receiving a single share of stock or even a thank you note. That is the human story hidden behind the technology story, and it matters enormously. It is a reminder that behind every gigawatt and every quarterly earnings call, There are real families quietly paying the price for a revolution they never chose. So here is the bottom line, the part you truly need to remember. The AI data center boom is real. It is massive, and it is reshaping the global economy, the world's electricity grids, and international competition in ways most people have barely begun to understand. But quantum computing is not some distant, harmless threat to this industry. The trillion-dollar question, and it is quite literally a trillion-dollar question given the money already committed, is no longer whether quantum computing will disrupt AI data centers. It is how fast. Every credible projection now places commercial quantum advantage within the next 3 to 5 years. Every major technology company on Earth is investing aggressively in quantum. Every government with serious ambitions has a national quantum strategy. And every data center being built today on classical assumptions is going to either evolve or be left behind. What we are watching right now, unfolding in real time, is the opening act of the most consequential technology transition since the birth of the internet itself. The companies that see it clearly will adapt and thrive. The ones that dismiss it as hype will find themselves clutching the most expensive obsolete hardware ever built. Quantum did not kill the AI data center with a single dramatic shot. It began something slower, deeper, and ultimately far more total. A disruption so fundamental that the industry may not fully grasp what hit it until the transformation is already complete. And when that moment finally arrives, the people who saw it coming, the ones who understood what was actually happening while everyone else was still arguing about electricity bills and gigawatts and quarterly earnings, will be the ones holding the future in their hands. Make absolutely sure you are one of those people. And if this story helped you see even a small piece of the future more clearly, then do one simple thing right now. Hit that like button and subscribe. Because from here, the story is only going to get bigger.